remember us talking about a nail being dropped in hydrochloric acid?
Not really.
You put it 0 there. Yep. Yeah, but you're taking their points and putting it in the slot. Okay. Okay, so we'll start here then. Okay, so what is the first thing that we're going to do? Let me read the question. It says, an iron nail is dropped into a solution of hydrochloric acid. So we want to figure out the net ionic equation for this. So what is going to be the first thing that we're going to do?
Put iron.
What was that?
Do you put iron plus hydrochloric acid?
So you got to tell me, I'm kind of green around the ears. Iron, what is the chemical symbol for iron?
Fe.
Oh, there, Fe.
Is it a solid, liquid, or gas? Or aqueous?
Solid.
Solid.
Okay, and what is it reacting with?
HCl.
Solid, liquid, gas, or aqueous?
Aqueous.
Aqueous.
And what are we going to make? What type of reaction is this?
Single
Replacement.
It's a single replacement reaction, right? It says it right on top of the thing, right?
Yes.
Okay, so what are we going to get? Who's going to be replacing who? Who's the old girlfriend? Who's going to be the new girlfriend? Or boyfriend?
FeCl.
Iron chloride.
So we're going to end up with iron chloride. So that's Fe what?
FeCl2.
Okay. So I'm going to tell you guys something real quick. So with transitional metals, almost all transitional metals, when you're doing a single replacement reaction, are going to be a +2, except silver. Silver is going to always be a +1 when you're doing a single replacement reaction. And let's see, aluminum is always going to be a +3, and gold is always going to be a +3. Okay, so silver, aluminum, and gold. Okay, are going to be your exceptions. Everything else is going to typically be a +2. So is that going to be solid, liquid, gas, or aqueous?
Aqueous.
And then what is going to be the other product?
Just H.
Is it just going to be H by itself? Just H?
Hydrogen.
H2. No,
H2, right?
Yeah.
Because we know that hydrogen is
the atomic.
diatomic. There we go. Okay, is it balanced?
No.
Okay, so what do we need to do to balance it?
Put a 2 in front of the HCl on the reactant side.
Okay, so we're good now?
Yes.
Okay, so we know that this is the conventional, right?
Yes.
So that's my abbreviation for equation. Okay, so if we're going to do the total ionic equation, so what are we going to do?
I'm gonna break them apart.
We're going to break them apart. The things that we can break apart. So what can't be broken apart again?
Oh, the solid. Well, I mean, like the ones that are not aqueous.
The ones that are not aqueous. So that's solid, liquid, gas, right? Or if it's a weak acid, right? So weak acids aren't going to be broken apart either. So then that means iron we're going to leave alone, right? So we're just going to drop it down as is. Okay, what are we going to do with hydrochloric acid?
Put 2H.
Or is there something that we need to do with that H?
Give it its charge.
Give it a charge. What is going to be its charge?
Just positive.
Okay, solid, liquid, gas, or aqueous?
Aqueous.
Aqueous, that's right. So because it's still in solution. Okay, then what?
We separate FeCl2.
Are we done here? Did we forget
Oh wait,
anything?
no, we need chlorine. I forgot. So it's 2 chlorine.
Okay, so 2 chloride, right? Because it's an ion.
Right.
Yep. So Cl minus AQ. Okay. On the other side,
Fe. That's a charge of 2 plus 2.
okay. Solid, liquid, gas, or aqueous?
I can say the word aqueous.
Okay. Chlor. Oh. And what else? What's next? Got ahead of myself.
2 chloride. Chloride.
Okay.
And then the power. Charge of negative.
Solid, liquid, gas, or aqueous?
Aqueous. And then you just drop the H2.
Okay. And we know that that's a gas that you're just dropping it. Okay. So that's our total ionic equation. So now what do we need to do to find out our net ionic equation?
Eliminate the ones that repeat.
Okay, so which ones are those?
The 2Cl.
Okay, so this one and this one. Anything else?
No, because on the reactant side, Fe doesn't have a charge.
That's right. It has to be exactly the same on both sides. Good job. So we end up with, oops. Okay? Questions, concerns, Cash?
Yeah.
Okay, excellent. So this allows us to talk about one other thing. Oxidation reduction. So I think we talked about this last time. So loss of electron oxidation. The way I remember it is Leo and gain of electron reduction. Okay, so let's look at this. So if you look at the iron, when iron is a metal, what is the charge on it?
Doesn't have one. Or
It doesn't have one. It has a zero charge, right? It's neutral. So all elements are neutral. So it's going to have a zero charge associated with it. I'm just going to write a zero on top of it. Okay, so here we go from 0 to a +2, right?
yes.
So is that losing electrons or is that gaining electrons?
Gaining.
0 to a +2. Is
Losing.
that losing electrons or is that gaining electrons?
Losing.
Losing.
That's losing, right? So because we know that electrons are negatively charged, so if I'm losing them, the thing is going to become positive. So iron is it being oxidized or being reduced?
Oxidized.
Being oxidized. Loss of electrons, oxidation. Okay. So by default, hydrogen is going from a +1 to a 0 because this is the element. So +1 to 0. So +1 to 0, are we gaining electrons or are we losing electrons?
Gaining.
Gaining.
Okay, so it's reduction, right? So it's being reduced. Okay. Okay, so this kind of makes sense, right? Because everything is about give and take. So somebody's going to be giving, that means that somebody has to be taking, right? So somebody's going to be giving up electrons, that means somebody's going to be taking. So iron is giving up electrons, so that means that hydrogen is going to be taking the electrons. You guys get that?
Yes.
Piece of cake?
Yeah, not too hard.
Yeah.
Okay, good. Okay, can I erase? Ready to move forward?
Yeah.
Okay, so if we have a reaction between zinc and copper 2 nitrate, so what is going to be the chemical equation? The conventional chemical equation.
Zn plus Cu NO3 with a 2 on it outside.
Then plus CuNO3.
Yeah.
Did everybody agree with that? Are we forgetting anything?
You put the 2 outside of the NO3.
Okay, so I put parentheses in the 2. Are we forgetting anything? Anything else?
The states of matter.
The states of matter. Okay, so what are they?
Zinc is a solid.
Zinc is solid.
Okay,
And copper 2 nitrate is aqueous.
and copper 2 nitrate is a solution, so it's aqueous. Okay, so what are we making?
Is it zinc nitrate?
Zinc nitrate,
Yes.
is that correct?
Do you put a parentheses in a 2 since zinc?
That is correct.
Okay.
We need our parentheses in a 2. Solid, liquid, gas, or aqueous?
Aqueous?
And then what is our other product?
Cu. Solid.
Okay. So that's our conventional equation. So what about our total ionic equation?
You just drop the Zn as like how it's the same.
Okay. Okay.
And then you split up the Cu with the positive 2 charge,
Okay.
and it's aqueous.
Okay.
And then you break up zinc nitrate, so you put Zn.
Are we forgetting anything?
Yes, I jumped a step.
2 NO3 with a minus charge and it's aqueous.
And now we can go to the product side.
It's Zn with a positive 2 charge. And it's aqueous.
Okay. And what else?
2NO3. It's a negative charge. And it's aqueous.
Okay. And what else?
Plus C, you just drop the CU.
Okay. Okay. So, we forgot one thing. Was it balanced up top?
No. Wait. Yeah. Wait.
Yeah.
Yeah, it was. I just thought I'd check. Okay. So our net ionic equation.
It's Zn solid.
Okay.
Plus Cu positive 2 charge aqueous. And then it's Zn plus 2 charge aqueous.
Okay.
And then plus Cu solid.
Okay. Questions, concerns, Cash.
Do we have to find the oxidation and the reduction or no?
Yes, we do.
Okay.
Okay, so which one is being oxidized? So this is, what is the charge on a element?
Would it be zinc?
We said what?
Would it be zinc?
Zinc. Zinc is being what? Oxidized or reduced?
Oxidized.
Oxidized.
Okay. So since we're going from 0 to a +2, that would be oxidation.
And then the other one is reduction.
I could spell. Okay. And then so copper is going to be
Reduction.
reduction. Okay, piece of cake.
Yeah.
Good. So I'd be prepared for that oxidation reduction stuff on the exam. Even though it's not on your practice test, you are going over a lot of that in your homework assignments. You have like 71 questions that technically was due on Friday, this coming Friday, but I postponed it till, well, I pushed it back to the end when your finals due. So
Thanks.
okay. Can I clear?
Yeah.
Okay, this is just that problem that we just did. Come Okay, so this is called the activity series table. Okay, so let me explain to you how it works. So metals behave in a hierarchy, right? So the higher you are on the activity series table, that means that you can replace those metals that are beneath you in a solution. So let me give you an example. We were talking about in our reaction just a second ago, we had zinc, solid, plus copper, 2 nitrate. Okay, so here's zinc, here's copper. Okay, since zinc is higher than copper, zinc can replace copper in solution. So then you'll get a reaction. Okay, you guys see that? Not too hard?
No,
Okay, was that no, you don't see it, or no, it's not too hard?
no, it's not too hard.
Okay, good. Okay, so let's say we switched it around. We're gonna mess things up a little bit here. So let's say we were gonna do. Okay, if I erase, I'm not really gonna erase. I'm just gonna shuffle. So we do this. So if we switch it around, zinc is higher than copper, right? So copper won't be able to replace it. So in this circumstances, there's not going to be a reaction. So then we're going to write NR. You guys get it? Do you see the difference?
Yes.
Okay. Okay, so let's test this out. Let's see how well you guys understand this. Okay. And then we'll start talking about water, because we'll talk about hydrogen, because hydrogen is a special case. Okay. So let's say we have okay. So are we going to have a reaction? And if so, what's going to be the product?
Calcium nitrate.
And what is the chemical formula for calcium nitrate?
Ca. NO3.
Is that correct?
Don't you put a parentheses?
Uh,
Then a 2?
Yeah,
outside?
and then 2.
Okay, solid, liquid, gas, or aqueous?
Aqueous.
And
Ag.
we know that's solid, right?
Yeah.
Piece of cake?
Yep.
Okay. So what about, yes.
Sorry, could you eventually show us the solubility table?
Yes, I can, if you are patiently waiting for me. Are you going to be
Okay.
patient with me?
Yeah.
Okay, good. Okay, so let's say we have okay, so are we going to have a reaction?
No.
Okay, I think I got it now. So it was an inert, no reaction, right?
Correct.
Let's see. Okay, so now let's talk about water or hydrogen. So if you look up at these, okay. If you look up at the boxes, can you guys see those boxes up there? So this first box where it has lithium, potassium, bromium, strontium, calcium, sodium.
Yes.
Yeah.
Okay, and it says we'll replace H2 from liquid water, steam, and acid. So in that case, these metals can replace the hydrogen in HCl or in water or in steam, right? So we'd have a situation where you have your lithium solid plus, let's say, H2O. So if it's H2OG, we know that that's steam, right? So it'll be able to replace it. And we'll get H2 and lithium oxide. Okay. So in the second box, all of these metals can replace H, hydrogen, in steam and in acid. And in the third box, all of these guys can replace hydrogen only in acids. So if you had water, it's not going to replace it. Okay? If you had steam, it's not going to replace it. It's only going to work in acids. And then these guys, since it's under the hydrogen, these guys aren't going to be able to replace it at all. Do you guys get that?
Kinda.
Okay, so let's say we have this. So what are we expecting in this case?
One of the elements in the first box.
What was that?
One of the elements on the first box.
So we have Cr reacting with water, liquid.
It doesn't. Right.
It doesn't. That's right. Because Cr is here, right? And it says it will only replace hydrogen from steam and acid. Well, that's liquid. It's not going to replace it.
Oh.
You guys get it?
Yeah.
Okay. So let's say we have. Let's go. Okay, so if we have nickel and hydrochloric acid, what's going to happen there?
The nickel's gonna replace.
That's right. The nickel's going to replace it. So you're going to end up with nickel 2 chloride and water. I mean, not water, and hydrogen gas.
Yeah.
Okay. You guys get it? Okay, so you have like 71 questions that are going to be basically asking you stuff like that. Okay. Okay. Okay, so not the last thing. Next thing I want to talk about is the oxidation of organic material. So when we talk about oxidation of organic material, we're basically saying that it's being burnt. That's the take-home message, right? So you're using the addition of oxygen to oxidize those components, okay? So write the equation for a complete burning of ethane, C2H6. not. Okay, so what am I going to do? You guys have been doing this since the dawn of time, pretty much, right? It's nothing new.
It'd be C2H6G.
Okay, sorry. Having a little difficulty here. There we go. C. It says C2H6G. Okay,
Plus O2. That would be CO2 plus H2O.
are we forgetting anything?
The
Not, oh, just gas. Gas.
Okay,
Um, so in combustion reaction, the H2O is gas.
yep. Yeah, because it's burning, right?
Yeah, okay. Then you have to balance it.
What's that?
You have to balance that one.
That is correct. So what do we do to balance it?
you add a 2 in front of CO2. And then
Okay.
a 3 in front of H2O. And then it'd be a 7 over 2 and O2. Then you'd multiply everything by 2, was it?
Okay. So then I'll get
2.
okay. Any questions?
I got a quick question.
Okay.
You added the O2 because it's burning, right? Or it's the burning?
Yes, that's right. Fires always require oxygen, right? So anytime you're burning a hydrocarbon, you always need oxygen. If you have no oxygen, it doesn't burn. Do you guys have candles, right?
Yeah.
Yes.
Okay. So tell me, do you guys buy the candles that have the lids? Okay. So if you light that candle, right, put the lid on top of it. What happens?
Fire burns out.
The fire burns out because it burns up all of the oxygen that's in that little area. If there's no more oxygen, it's not going to keep burning. Now, if you keep it open to the air, then what happens?
It keeps burning.
It's going to keep burning.
Subpar, because I'm on fucking mic. Where are you from?
Okay.
Oh, okay. I'm from California. California.
Questions, concerns, Cash? Good.
I'm 21. Have a wonderful day.
Okay. As promised. So when we talked about a double replacement reaction, we also have precipitation. Precipitation, one thing is going to precipitate, the other thing is going to remain soluble. Solubility represents things staying in solution. That's what soluble means, right?
Here.
So what am I supposed to do? Namaste.
Okay, so, oops, these are solubility tables, right? So if you take a look at this table, right? Let's say we have aluminum.
What?
Aluminum chloride. And that's going to be reacting with barium hydroxide. Okay, so if we have aluminum chloride, aluminum, and then you go to chloride, that's going to be soluble. So we're going to put it in solution. It's going to be aqueous.
Bro, what the fuck? You good? Like, is that an audition?
Okay. Okay, what about barium chloride? Is that going to be a solid or is it going to be aqueous?
No, no, no.
Aqueous.
Hi.
Okay, so double replacement. So that means that you're swinging, right? So you're gonna, this guy is gonna now react with this guy. Got to put the two there. And then this guy is gonna react with this guy, right? So we have barium chloride So what does barium chloride look like? So it's Ba what? Bl.
Verona.
The parentheses on the chlorine, it has a 2.
What is that?
CO2.
It has the parentheses and the 2 on chlorine.
Okay. No parentheses, but it has 2,
Okay.
right? Since there's only chloride there. Okay, and then is it going to be solid, liquid, or gas? Solid, liquid, gas, or aqueous?
I went to the hospital and I got checked.
Okay, so we check it out. Barium chloride. Okay, so that means it's soluble, so that's aqueous.
And mine's reading. Okay, go for it.
What about aluminum hydroxide? It's going to be Al what?
No.
Is it a solid?
AlOH3, and it's going to be a solid. So how did you figure out it's going to be a solid?
Because it says nearly insoluble.
Okay, because it says nearly insoluble. So if we go aluminum all the way to hydroxide, nearly insoluble. So anything that's in pink is going to form a precipitant, right? Some of the things are going to be slightly soluble, but basically that means that most of it is insoluble. Only a little bit is going to be soluble, okay? So if it's in pink, it's going to form a precipitant. It's going to form a solid. So then you're going to put an S. Does that help you understand the table?
Yes.
Yes.
Okay. So let's see how well you got this. Okay, so if I have copper phosphate, is that going to be a solid, liquid, or solid, liquid, gas, or aqueous?
Hi. Go on.
Which copper did you say?
What's up?
Copper to phosphate.
Gonna be a solid.
Hello. How are you?
Okay.
Are you doing the renegade? I'm confused.
That is correct. What about
Some silence.
calcium iodide?
Soluble.
Aqueous.
Aqueous.
Okay. Okay. Piece of cake, not too hard.
Yeah.
Yeah.
Okay, good. Sorry, I'm trying to do 2 things at once. We're trying to get them to see about getting me another computer. Okay, so
Handsome. I'm a girl.
okay, so let's see.
I've never heard that.
Get this next part. Got it. Doing something
I
crazy.
don't know. I usually tell guys they're handsome, you know? Thank you. No, but I don't mean to be rude. I was just like, I've never heard that. I'm from
Really
California.
does not want to work for me today. Okay, so this is the hard way of doing solubility. So on your exam, you have this in your resources. I'd print it out and use my solubility table, the one that we just had, if I can get it to go back. Okay, so I'd use my solubility table to sit there and help me figure this out. Okay, so you're able to use this on your exam. Are you guys good? Is that okay? Or do you want me not to let you use it?
Yes.
No, it's okay.
It's okay?
Yes.
Yes.
You guys don't want to be challenged and try to remember all of this?
Oh God, no.
Nope.
Okay, so if we have a solution of lead 2 nitrate and sodium bromide are combined, so let's write the net ionic equation. Okay, so if we go back to that table, so we're looking for, sorry, lead 2 nitrate. So lead
Soluble.
2 nitrate. So it's soluble. And then we have sodium bromide.
Soluble.
Okay, so let's write that down. So lead 2 nitrate
One more.
is Pb
NO3.
NO3
2.
parentheses what?
2.
Okay. And we know that that's soluble, so we put an AQ plus sodium bromide.
Where
Is
do you really want
NABR.
the electric toothbrush? I really want a fucking sonic toothbrush.
And we know that that's solid, liquid, gas, or
Aqueous.
aqueous. Okay, AQ. Should use a different color than red. Okay, and then what are we gonna make?
That's probably a lot. You probably haven't heard that one. It's kind of like great purchase though. It's like they're kind of expensive and
B.
good gift.
PBBR. 2.
No stress. You're fine. Have a good rest of your day.
You said PBR2.
Yes.
Okay, solid, liquid, gas, or aqueous.
Solid.
Solid.
Plus
NaNO3.
solid, liquid, gas, or aqueous.
Aqueous.
Gotcha.
1, 2, 3. Oh yeah.
Okay. So that would be the conventional equation. So for the ionic equation, we need to break it down, right?
Are you supposed to balance it or no?
Yes, let's balance it first. Good job. Catch me with my pants down there. Okay, so what do I need to do to balance it?
Put 2 onto NABR.
Okay,
And 2 on NaO3.
okay, piece of cake.
Yeah.
Okay, so now if we break it down,
You're being big. Should I convince someone?
what are we gonna have? What are our ions?
PB2 plus.
Pb 2 plus.
How you doing, sir?
Aqueous.
Okay,
By what?
Oh.
What does that mean?
Plus 2 NO3 minus.
I do. I've actually noticed it a lot lately. But also I'm like looking down and the camera's right here. So like, you know.
okay,
Cali.
plus.
Plus 2 Na plus. Aqueous.
It's like 68 right now. I would say maybe like 65.
Sorry, I know that looks crazy.
Huh? Fahrenheit. Yes.
Plus
But it's tight.
2 BR.
2
Degrees Fahrenheit. How do you change it to Celsius? What? My sister's doing it. She's like,
aqueous, right?
Yeah.
Okay, and then we're gonna make.
where are you from?
You leave the PBBR2.
Out there?
Okay, we're gonna leave that alone. So PBR Cr2.
It's okay though, like when it gets really cold here, it gets very cold. Like, and it's gonna start getting cold. In some parts, but
Plus
2Na plus.
no. I'm by a beach.
Multiple beaches, actually.
No, I wish.
I can hear Vivian talking.
what was that?
I can hear somebody's background.
Yeah. I mean, I love the
Plus, you said NO,
And is it you have to put in?
NO3 minus,
Yes.
and there's 2 of them.
Yes.
Yeah. Yeah.
Okay, piece of cake. That's it.
Oh.
Oh,
Are
now
we
what do we
doing
need to
the
do?
Ionic one, doctor, or no?
Yeah, this is the total ionic. So the net ionic, we need to do what?
Yeah, it's good.
Take out
The spectator.
Okay, who are our spectators?
the NO3 minus
Okay, so
And the Na, 2Na.
and Na plus. Yeah.
okay, so we have NO2 minus right here. Get rid of that guy. Get rid of, and you said the Na
Yeah.
plus. Yeah, there we go. Okay, since I ran out of room, I'm just going to erase them. If I can get it to erase. Struggling today. Okay. I am not lying. Ooh, it is really trying to fight me on everything. My computer says I've had enough. It's ready for break.
I'm ready for a new one.
Yeah. Okay, so we end up with okay. Yeah, count those. It doesn't matter. El Pestro. 3. No, on the side. Thank you. Okay, this is ridiculous. Okay. Okay. Questions, concerns, cash. Cash, cash. Or cakes. So how do you guys feel so far?
Pretty
Yeah.
good.
Pretty good?
Pretty
Okay,
good.
hold on, there's something in the chat. I like that. Okay, so let me clear. See if I can get it to move forward. Come on. Come on. Let's see.
Oh, there you go.
Okay, so now this is going to work the same way when you're working with acids, because again, an acid is just a special case of an ionic compound, right? The only thing is that with an acid, if you have a strong acid, strong base, you're going to end up with water and a salt, okay? So if we have hydrochloric acid and sodium hydroxide, we're going to end up with water and sodium chloride, right? And so again, the breaking down procedure is going to be exactly the same, okay? So you guys can do this on your own. I don't think you need me to do it for you. Okay, if my computer continues to work. Yeah, yeah. Yeah. Okay, that's fine. Darn it. Okay, so what's important also is that when you bring certain things together, so like if we get hydrogen and carbonate together, it's going to form carbonic acid. Well, carbonic acid is unstable when it comes together. And so it's going to be broken down almost instantaneously into carbon dioxide and water. Okay, and that's the same thing when you have the hydrogen ion or the hydronium ion and sulfate or sulfite. You're going to form, in this case, sulfurious acid. It's going to break down almost instantaneously to sulfur dioxide and water. And then when you have ammonium and hydroxide, it's going to form ammonium hydroxide, and it's going to break down almost instantaneously to ammonia and water.